We will now solve problem 4, given in the exam in the fall 2017. Okay, so we are giving the population in a town, and it is increased exponentially. If it has increased exponentially, we can write it in this form here, where k has to be positive. If k is negative, then we have a decrease. But since we now have the case positive, we have an increase. We also are given two different values here. We have 20,000 in the population 2005 and 35,000 in 2015, 10 years later. And then we have the model thing here with the P of t, and t is the time in years after 2005. So first we want to determine the constants P, O, and K. So if we start with 2005, then t has to be 0, because t is the time in years after 2005. And the population would be 20,000. If we use our formula here, or our model, we have PO e to the k times 0, which means that we get only PO. So, since that one, PO has to equal 2020, because this P of 0 has to equal both 2020 and PO. Okay, in 2015, T has to be 10, since we're now 10 years after 2005, and P of 10 has to equal 35,000, given from the text up here. Okay, so P of T10 has to be PO e to the k times 10. PO is equal to 20,000. The thing now is that we have two expressions for P of t, so this gives us that 35,000 has to equal 20,000 e to the 10k. We often put the unknown last. Okay. In order to solve this, we first divide by 20,000. So we get 35,000 divided by 20,000 on the left side, equal to E10k. That gives us 1.75 if you write it like this with decimals, or with more like this. That's up to you. In order to solve this, I take the natural logarithm of both sides. The reason why I take the natural logarithm is that I have an e here. So if I take ln of e10k, I can put 10k in the front, and then ln of e, and that gives me ln of e is equal to 1, so I get 10k. So this is on the side, and you don't have to include that. So finally, let's just switch places here. So now the right side is my left side, and so on. So k now would be ln 1.75 divided by 10, which is more or less 0.056. So now I have both PO and K, and that was what I was asked for. So always check after you've done something to make sure you have all the answers. Okay, in B, find the first derivative of P. So that's the first answer. And what was the growth rate of the population in the beginning of year 2010? So let's start with the derivative, the first derivative. So we have P of t equals to P O E K T. P derivative of that, PO is simply a constant that we multiply with. And here we get K E K T. You could either use the formula sheet or whatever you want. If you have it in your head, use it. You could also put in the constant that we found in A if you want to. Okay, so that was the first derivative. But we also asked for the growth rate of the population beginning of year 2010. In the beginning of the year 2010, we need to find t. T is the time in years after 2005. So in 2010, t has to equal 5. So p derivative of 5 would then be 20,000 times 0.056 e to 0.056 times the 5, which is approximately 1480. So in the beginning of the year 2010, the growth rate was approximately 1,480 persons per year. So in the beginning of the year 2010, approximately 1,480 persons per year was the increase in the population. The reason why I wrote this in text is that I'm asked in text. Therefore, I need to answer also in text. Now I've answered everything in B, and then I'm asked in C, in what year can we expect that the population becomes larger than 50,000? So I have an inequality here where I need to find when POT is more than 50,000. Okay, so I put in my values here. 0.056, the K should be larger than 50,000. I divide by 20,000. So I get E 0.056t should be larger than 2.5. I use the natural logarithm on both sides. And then I get 0.056t on the left-hand side and ln of 2.5 on the right-hand side. And then I get t larger than ln to 2.5 divided by 0.056. The reason why I do not calculate ln earlier on is that I will get some decimals, and that will make my calculations less accurate. So I do all the calculations in the end. So 16.36. So the population becomes larger than 50,000 during the year 2005 plus 16. So 21. No, 2021, sorry. So that's when the population is expected to get larger than 50,000. Is that what we ask for? In what year can we expect that the population becomes larger than 50,000? Yes, that's what we are asked.